Imagine waking up one morning before your alarm clock even rings. The curtains slowly open by themselves. The lights automatically adjust to the brightness of the morning sun. The air conditioner sets the room to your preferred temperature. The coffee machine begins brewing your favorite coffee. Your smartwatch has already monitored your sleep throughout the night and prepared a report waiting on your phone. Meanwhile, your refrigerator notices that you're running low on milk and quietly adds it to your shopping list. Outside, your electric car has finished charging during the cheapest electricity hours. And all of this happens without a human controlling every step, without someone pressing buttons, without someone giving commands every second. Instead, these devices are communicating, sharing information, responding to one another, working together automatically. Welcome to the world of the Internet of Things, or IoT, one of the most transformative technologies of the modern age. A technology that is quietly connecting billions of devices across the planet. Not just computers, not just smartphones, but refrigerators, cars, security cameras, streetlights, industrial machines, medical equipment, home appliances, and even entire cities, all connected through the internet, all exchanging information, all working together in ways that were once impossible. And although millions of people use IoT technology every single day, very few stop to ask a fascinating question. How do these devices actually communicate? How can a thermostat talk to an air conditioner? How can a smartwatch monitor your health? How can a factory machine warn engineers before it breaks down? How can thousands or even millions of devices coordinate with one another without direct human involvement? To answer these questions, we must begin with a simple idea. What exactly is the Internet of Things? When the Internet was first developed, its purpose was relatively straightforward: to connect computers. One computer sends information. Another computer receives it. Data moves across networks. Messages travel from one point to another. Simple. But eventually, engineers began asking a bigger question. What if the internet connected more than computers? What if everyday objects could also connect? What if a light bulb could send information? What if a door lock could receive commands? What if machines inside a factory could communicate with one another automatically? What if an entire city could monitor itself? This idea became the foundation of the Internet of Things. The concept is surprisingly simple. The Internet of Things is a network of physical objects connected to the internet that can collect data, exchange information, and sometimes take action automatically. The key phrase here is physical objects, because before IoT, most objects were isolated. A refrigerator cooled food. A lamp provided light. A car transported people. Each device performed its own function, but none of them truly communicated. None of them shared information. None of them were aware of their environment beyond their immediate purpose. IoT changes that completely. It gives ordinary objects a digital voice. It allows them to collect information, share information, and act upon information. And once information begins flowing between devices, extraordinary things become possible. But how does an object become part of the Internet of Things? The answer begins with sensors. Sensors are the eyes, ears, and senses of IoT devices. Without sensors, devices cannot understand the world around them. A temperature sensor measures heat. A motion sensor detects movement. A humidity sensor measures moisture. A pressure sensor detects force. A camera captures visual information. A microphone captures sound. A GPS sensor tracks location. An air quality sensor measures pollution levels. Every sensor performs the same basic task. It converts something happening in the physical world into digital data. Imagine a smart thermostat. Its temperature sensor measures the room temperature. That measurement becomes digital information.
And once information becomes digital, it can be transmitted.
This brings us to the second major component of IoT: connectivity. A sensor alone is not enough. The information must travel somewhere. Devices connect using different communication technologies: Wi-Fi, Bluetooth, cellular networks, 5G, satellite connections, and specialized IoT communication systems such as LoRaWAN and NB-IoT. Each technology serves a different purpose. A smartwatch might use Bluetooth to communicate with your phone. A security camera may use Wi-Fi. Agricultural sensors located in remote fields may rely on satellite communication. Industrial machines may use dedicated wireless networks. But regardless of the method, the goal remains the same: move data from one place to another. Once data reaches its destination, the next step begins: processing. This is where things become truly interesting. Many IoT systems do more than simply collect information. They analyze it, interpret it, and make decisions based on it. Imagine a smart air conditioner. Instead of simply turning on and off, it studies your habits. It learns when you usually wake up, when you leave home, when you return. It notices seasonal changes, weather conditions, energy costs, and gradually it optimizes its behavior. Not because it is intelligent like a human, but because it uses data to make better decisions. Now imagine this happening not with one device, but with millions, billions, every second, every minute, every day. Data flowing continuously between homes, vehicles, hospitals, factories, power grids, transportation systems, and entire cities. This interconnected network is what makes IoT so powerful. Because the real strength of IoT does not come from individual devices. It comes from connections. Connections create awareness, and awareness creates efficiency. Let's consider one of the most familiar examples: the smart home, a concept that once sounded futuristic. Today, many households already use smart devices: smart lights, smart locks, smart thermostats, smart speakers, smart cameras. Imagine leaving your house. The security system automatically activates. The lights switch off. The doors lock. The heating or cooling system adjusts to save energy. When you return home, your smartphone signals your arrival. The lights turn on. The temperature adjusts. Your favorite music begins playing. Everything happens automatically. Not because the house is alive, but because devices are communicating through IoT networks. Now expand that idea beyond a single house. Imagine an entire city. Streetlights equipped with sensors. When no one is nearby, they dim to save electricity. When pedestrians approach, they brighten automatically. Traffic sensors monitor vehicle flow in real time. Traffic lights adapt to changing conditions. Parking systems guide drivers directly to available spaces. Waste bins report when they are full. Garbage collection routes adjust dynamically. Water systems detect leaks before they become major problems. Public transportation responds to passenger demand. This is the foundation of the smart city, a city where infrastructure becomes aware, responsive, efficient, and connected. But perhaps one of the most important applications of IoT can be found in industry. This is known as the Industrial Internet of Things, or IIoT. Modern factories contain thousands of sensors attached to machines. These sensors monitor temperature, pressure, vibration, energy consumption, production speed, and countless other variables. Traditionally, machines were repaired after they failed, but IoT changes this approach. By continuously monitoring equipment, systems can detect early warning signs. A motor may begin vibrating slightly more than normal. A bearing may heat up unexpectedly. A machine may consume more power than usual. These tiny signals can indicate future problems. The system alerts engineers before a breakdown occurs.
This is called predictive maintenance, fixing problems before they happen. The result is reduced downtime, lower costs, and greater efficiency. Healthcare is another field being transformed by IoT. Wearable devices now monitor heart rate, blood oxygen levels,
Sleep quality, physical activity, and other health indicators. Patients with chronic conditions can be monitored remotely. Doctors receive real-time information. Potential problems can be detected earlier. In some cases, lives can be saved because a device noticed something unusual before symptoms became obvious. Imagine a future where healthcare is continuous rather than occasional, where monitoring happens every day rather than only during medical appointments. That future is already beginning. Yet, despite all these advantages, IoT also introduces serious challenges. The more devices become connected, the larger the cybersecurity risk becomes. Every connected device represents a potential entry point. If security is weak, hackers may gain access. A compromised smart lock, a vulnerable security camera, a poorly protected industrial system. The consequences can be significant. Privacy is another major concern. IoT devices collect enormous amounts of information: location data, behavior patterns, health information, energy usage, daily routines. The question becomes, who owns this data? Who can access it? How should it be protected? And how much information are people willing to share in exchange for convenience? These questions will become increasingly important as IoT continues to expand. But despite these challenges, one thing is clear. The Internet of Things is no longer a vision of the future. It is already here. Inside our homes, inside our vehicles, inside hospitals, factories, airports, cities, and even the devices we carry every day. Experts estimate that tens of billions of connected devices will exist in the coming years, creating the largest digital ecosystem humanity has ever built. A world where objects no longer remain silent. A world where machines exchange information continuously. A world where technology becomes increasingly aware of its surroundings. Because ultimately, the Internet of Things is not simply about connecting devices. It is about connecting the physical world with the digital world, creating systems that can sense, communicate, respond, and adapt. And perhaps one day, when nearly every object around us is connected to a vast, intelligent network, we will no longer think of connectivity as something special. It will simply be part of everyday life, as ordinary as electricity, as common as running water. And when that day arrives, we may look back and realize that the Internet of Things quietly transformed the world around us, one connected device at a time.